Yeah, yeah.
Yes. How's the team doing?
Everything is good.
All right, great. So
All
we
right,
wish you all
thank
the
you.
very best, yeah?
All
Now
right,
that
thank
we have
you.
the teams introduced, let's see for the benefit of our team members here today, who will be our judges for this afternoon's program and hearts of our hopeful engineers to win. So ladies and gentlemen, presenting our judges for today, firstly, Mr. Ricky Steen, Country Managing Director of edotco Bangladesh, who will also be our Chief Judge. How are you, sir?
I'm fine, thank you. Hello, everybody, and good luck to all the contestants.
All right. How's things in Bangladesh?
It's great. Thank you very much. The sun is shining today. Summer has started.
Wow. Okay. Great. 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 Nice seeing you, sir. Okay. Moving on. The next judge will be Encik Abdul Yazid Kasim, Director of Group Engineering Technology, edotco Group. How are you, sir?
Yeah, Alhamdulillah, I'm good.
Alhamdulillah.
All the best
This
to the
time-
team, yeah.
Sorry, again?
All the best to the team.
All right, great, great, great. And the third judge that we have for this afternoon is none other than Associate Professor Dr. Siti Amina Osman, Deputy Dean, Networking and Alumni from the Faculty of Engineering and Built Environment, UKM Malaysia. How are you, Doctor?
I'm fine, Alhamdulillah.
Would you like to share a bit on your hopes for today's presentation? Just one final bit of advice for the team.
Just good luck to all the presenters.
Okay. Thank you, Doctor. Thank you to all our three judges. So with that brief introduction of our aspiring teams and esteemed judges out of the way, are we ready to commence the finale of edotco Design Competition 2022? Teams, are you ready?
Yes.
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 Right, judges, are we ready?
Yes, we're always ready.
Okay, Alhamdulillah, and we wish everyone the very best of luck. And just before we start, each team will be given 10 minutes to present their ideas and innovations to our panel of judges, and thereon take a 5-minute question and answer session to explain further on any notes with regards to the presentation. So with that, ladies and gentlemen, I'm sure we are all towered up to get the show started. And without much further ado, it gives me great pleasure to invite the first team this afternoon. Please welcome Team Aliang Tower from the National University of Malaysia. Yeah. Okay, Team Aliang, the floor is yours.
The slide, is it sharing the slide right now? Yes. Okay. First of all, good afternoon to the moderator and panels. My name is Chin Liang. Today, with my group members, Lau Yung Chin, Goh Shen Ho, and Lin Yong Liang, we're going to present our project design, which is Aliang Tower. Next slide, please. Now, let's take a look at the overview of Aliang Tower. The tower design is camouflage monopole with area of site layout of 6 meter times with 6 meter. The loading of the tower is designed according to TIA 222G and implement CFDSD to the tower body. Meanwhile, the footing of the tower design is according to ACI 31805 by using GFRP bar as a reinforced bar. Next slide, please. The camouflage monopole able to blend well with the environment, and installation of the tower itself is easy. By using CFDSD, the tower bodies of the monopole is able to provide a high performance in terms of strength of the tower. The GFRP bars provide good resistance to corrosions, but also providing 2 times of tensile strength compared to normal steel bars, and is light in weight too. Next slide, please. So as we can see here, this is the plan view and the elevation views of our tower. There are the cabins, fences, and the towers. And at the elevation views, we can see that they have synthetic branches and leaf at the tower. Next slide, please. So I would like to pass my baton to Yong Liang.
Thanks to Jia Liang. Next, I will continue with gate, fencing, and cabin design.
For the fencing dimension, we are using 6 meter times 6 meter with 2.6 meter height and 0.95 meter depth for the fencing footing. All the footings are designed with 2 meter spacing as shown in the figure at left bottom. For gate design, we are using Swiss gate with dimensions 4 meter width and 2 meter height. Next slide, please. For our cabin design, is using reinforced concrete design with dimensions 3 meter times 3 meter. Following figure show the details of pad foundation, slab reinforcement, and beam reinforcement key plan. Next slide, please. In this slide, show the 3D modeling of cabin by using STEAM and cabin roof truss model by using StatPro. Next, I shall pass my speech to Lau to continue the presentation with monopole design.
Now we will look forward into the monopole design. So TIA 222G is used as our design chord, and 3 CFDST sections is proposed. The first, second, and the third section had the length of 15 meter, 10 meter, and 8 meter respectively. All the diameter of the steel tube are recorded in this table. Furthermore, type of the steel grade, steel thickness, grade of the concrete fill, and the connection method being used in this project are also recorded in this table. Next slide, please. Next slide, please. Okay, this slide shows the 2D and the 3D drawing of the monopole. So from the figure, we can see that the synthetic branches and the leaf are well along the section of the monopole. At the bottom of the monopole, we can see that the CFDST is connected to the base plate. There were 2 doors installed at section 1 and section 3. There will be ladder installed inside the inner tube. Next slide, please. On the other hand, this slide shows the detailed drawing of the monopole cross-section, detail of the flange connection, cross-section view of the ladder inside the inner tube, and the detail of the ladder. Next slide, please.
Thank you, Lau. Now let's look into the outcomes of the foundation's design. First of all, the foundation design requirements are based on the code ACI 318-05. The proposed foundation type is the simple pad footing. At the same time, we introduce the GFRP bar as the reinforcement. The dimension of footing, concrete grade, and the number of reinforcement are also tabulated in this table. The arrangement of reinforcement is presented in the following drawing. Next slide, please. From the plan view of the footing on the left, 12 bars are placed in the short direction, which is vertical from our side of view, and the 15 bars are placed in the long direction, which is horizontal from our side of view. Each of them is arranged on top and bottom of the footing. Look at the reinforcement arrangement in the right figure. 8 bars with spacing of 100 are arranged in the splice with 910 and depth, where the rest of 3 bars are arranged in the remaining splice with the spacing of 25. Next slide, please. Here comes the bill of quantity for the project. There are the BOQ for the foundation and tower. Next, please. There are the BOQ for the appurtenance and the fencing. Next. Last but not least, this is the BOQ for the cabin and mortar. Next. All right, that's all from Alliang Tower. Thank you for your attention.
Judges, we are open for Q&A for the questions.
If I may, what type of tree is this? Is it a palm tree or what type of design that you have in mind?
Team, you may answer Mr. Sting's question.
Sorry, can you repeat again?
Yeah, I just would like to know, is it the tree, the camouflage, is it a specific type of tree that you are mimicking? Is it a specific type of tree, for instance, a palm tree or?
We basically want to make it. We will weld the leaf to make it blend well in the environment. So we're not sure which type of leaf we will use, but basically we will refer to the palm tree.
Okay. Now I just wanted to get a feeling if there's a specific type of tree you were aiming to copy.
Any further questions from our panel judges?
Okay. Sorry.
Okay, Doctor, go ahead.
Okay, thank you. What made you choose to have GFRP instead of the normal normal bar?
May I answer your questions? Okay. The reason why we're using GFRP bar is because due to its high tensile strength, it provides 2 times of the tensile strength compared to normal steel bars. And furthermore, that this type of steel bar have a high corrosion resistance compared to steel bars. So it would more benefit in the long term. So which means that there will be less maintenance to the tower itself for the steel bar. Yes, that's all for my answer.
Okay, looking at your foundation, your tower is, if I'm not mistaken, about 30-meter height, and your footing, don't you think like a bit smaller, 1.6 by 1.6 times 250? What type of bearing capacity considered for this design?
So this question I pass to Jess.
All right, I will answer on this question. The bearing capacity I will be selected on 150 kilonewton per meter square. It's some kind of strong soil under the foundation. Am I answer your question?
Yeah, what about the thickness of the slab? I look at it, your pad footing is not that thick. Yeah, very, I can see very minimum 250. Don't you think that to hold the tower up to 30 meter, can it withstand with this wind drag, things like that?
Because based on the code, design code, so I design accordingly to the code. So I found that even the thickness is only 250 mm, but reinforcement is still required so that to withstand the shear existed due to the wind or even the load from the tower. That is what I get from the design.
Right.
Yep. Any further questions from our panel judges?
Sorry, one more. Maybe somebody can talk me through the grounding methodology, and the foundation and to the tower. How is that captured? I don't see it in the BOQ.
Sorry?
The grounding methodology, the earthing of the structure itself and the foundation, and of course your gates, all needs to come to a earthing position, right? A grounding position. Did you take that into consideration in the design?
Do you mean by excavation, the excavation or
the lightning? I
The
think
lightning.
referring to the lightning for your earthing.
Correct.
Oh, okay.
For 30
For the
meter, height structure, you should have like earthing, on top, like a copper strip going down straight from the pole to the ground.
So
that one we not consider.
Yeah, usually in your foundation there is the grounding, right, and then all of your gates also comes to this grounding points. Okay, thank you.
We don't consider it.
Yeah. Okay, thank you.
Okay, thank you, judges, and thank you, team. Aliang Tower from the National University of Malaysia. Well done on your presentation. and we'll move on to the next group for our session. Thank you, guys.
Thank you.
Thank you.
Just give a couple of minutes. We are doing a bit of a transition before we invite the second team here, judges.
Hello. Can you hear me?
Okay. Next, can we invite Team AUPP Group from the American University of Phnom Penh, Cambodia? And the slides are ready. The floor is yours, sir.
Okay. So, hello, judges and expertise from edotco Group. My name is Usapir Supanat, and my teammate name is Samsung Metana. And our group name is AUPP Group. So, both of us are senior civil engineering students from American University of Phnom Penh. And today we will present our design on edotco cell tower. So, here's what we're going to talk about throughout the presentation. First, we will briefly talk about our technical design, for example, how we did the project or how we come up with the design. Secondly, we'll talk about the material for our cell tower. And the last one, we will cover the benefit of our design to the environment, society, and to edotco business operation as well. But I will only spend a little bit on technical design. And if you want to look at more, you can see our report. So since our time is limited, and I will spend the rest on material and benefits. So let's start. How did we design the projects? Actually, we use two different approaches. First, we do the basic design with our hand calculation for beam, column, and member. But then we use our software to verify our data. We use two different software. For instance, we use design tower and robot structural analysis to do the analysis of a tower, and we use Revit structure to do the shop drawing 2D and 3D. So here's the result of our result and major takeaway. We conclude that our foundation and combined footing itself, reinforcement of our foundation is within the limit of requirement as well. And the peer design is also working well without any error. So we use Design TNX as our main calculation since it has all the code requirement. However, there are still some limitation to this software. For instance, it can calculate the foundation, slab, column, or ladder. That's the reason that we introduced the second software called robot structural analysis to fill the lack of Design TNX. And the result of both calculation is slightly different. Since in robot structural analysis, we include the dead load and live load of the slab, dead load of the foundation, and column and ladder as well. And that's why the result in robot structural analysis is higher than the design tower. I already include the result in my report as well. So of course, so we can say that both of the design is the same. Our structural integrity is fine. And now let's move on to the second section. We actually at first we have considered many material for our design. We consider carbon steel, high carbon steel, engineering timber, but finally we go to decide with our fiberglass after a long period of intensive research regarding this material. This is all the main properties of the fiberglass. But I won't go like all of that one by one. I just summary that the strength of the fiberglass is that it has durability than steel and wood. So let's start with the application of fiberglass. Just a side note that the fiberglass is not a new type of material. The fiberglass has been experimenting for a long time already. The application of the fiberglass also improved day by day. And many material scientists believe that this will completely replace steel in the construction industry in the future. For instance, there were several case studies as well. We have Dr. Stenberg and Dr. Johnson from co-author from University of Arizona, Tucson, and they have a study for structural analysis of fiberglass antenna tower. So This paper is really wonderful, and according to my research, this paper proved that the fiberglass is a really good material for the next generation of tower. Dr. Stenberg and Dr. Johnson wrote that the use of fiberglass provides a design that not only met structural requirement but ease transport, simplify erection, and improve maintenance. So fiberglass can replace steel, and because it is better and most importantly, it met the structural requirement. Moreover, we have Ohio Department of Transportation make a statement that unlike steel rebar, fiberglass rebar doesn't rust. So the concrete deck structure doesn't degrade as quickly and increase the longevity of the structure. Plus, the composite rebar is lighter, so it's less expensive to deliver and faster to install. So there are several more cases regarding the fiberglass, but I won't cover all of that. This is the real application of fiberglass in China and in Thailand. And I can see in Cambodia that the fiberglass has been widespread in the form of a scaffolding that have been mass produced by China. And we also have the big application of fiberglass. For instance, on the top right is it's called Tower on the Mome. It's called a fiberglass tower. It can be considering the groundbreaking of fiberglass in May the 1st, 1967. So, and the lower left is called Anthony Wayne Thread Bridge Replacement Project. The first of all, the bridge is made of steel. Steel rebar and steel bridge, but it do the replacement project with the fiberglass, and the result is also better than steel as well. So wait. So let's move on to the last section. First, the fiberglass is a natural choice when you are seeking energy efficiency and green sustainable solution. Due to its composition, fiberglass is known for very low total energy produced. So sustainability starts with sand, an abundant natural resources. The main ingredient in fiberglass is glass. Since glass is made from sand, an abundant, natural, non-depleting resource, fiberglass is highly sustainable solution. So the second one is energy saving. As I've mentioned above, the manufacturing of the fiberglass is far less energy intensive process compared to many other construction materials. However, there are plenty of other ways fiberglass can help energy consumption. For one, fiberglass features terrific thermal insulation. It has thermal conductivity that is 500 times less than aluminums. And one of the most notable is that the fiberglass has a lesser carbon footprint than most of material, making it eco-friendly. If you compare the steel or concrete, it only releases half of the concrete and a third of the steel. So the fiberglass lasts longer than most materials since it has a really high tensile strength. And the fiber it is resistant to most substances such as acid-based oxidizing agents, so it won't easily rust. And I think this is important for our tower. And so the last one is that it saves a lot of money and time, because yes, it costs higher than steel, but it's easier to maintain compared to wood and steel. So it is a good investment in long run. And in conclusion, I think it saves the organization a lot of money, and due to its installation are faster than steel or wood or most material. So I think this is the most optimal material for the next gen tower. That's all for my presentation.
What is the lifespan of these structures, and in terms of operations and maintenance, how does that work? Maybe you can just talk me through that.
Actually, when I done the research, they said that this type of structure lasts much longer than steel. It built for decades. Yes.
Is there any sort of treatment that we have to apply to ensure that we keep this or extend the lifespan of this? And maybe like a resin paint, or no other treatment required?
Wait, I don't think we need to have more treatment for the extended durability, because the material itself is already improved to be last longer.
Thank you.
Thank you.
Okay. You did mention about the cost of this GFRP. Is much higher than the steel. So, but at the end, you said that it will give a cost saving in a long time. So, how many percentage if you compare with the steel just now?
Actually, this is I consider this as well before. Yes, it bill a little bit higher. Its cost is higher than steel, but it doesn't require much maintenance steel. Like for steel, you have to do the fixed maintenance of at least a year, a fixed interval of maintaining in a year. But in the fiberglass, you don't need to do that. You need 5 years, and it's very easy to maintain. You don't need to paint it like steel to avoid corrosion. No, the fiberglass is already a material that avoid corrosion itself. Yes.
So in your design, you're going to use the GFRP for the whole tower?
No. GFRP is a type of fiberglass, but it's for the rebar. But use the fiberglass protrusion. Yes. That is the case study.
All right. Okay.
All right. What about the UV exposure, ultraviolet exposure for this?
Wait a minute. Report, Brian. I'm sorry about this one. Wait a minute. Can you give me a minute for this one? The implementation. Oh yes, the fiberglass is resistant to water and chemical, and including chlorine. So the product is very resistant to the UV radiation, lowering the risk of the sun, and bleaching and retaining increased coloration for a longer length of time. We actually do the report on this one in our submission. We just forget about that. It's been a long time. Yes.
So just echoing what Ricky said just now, on the maintenance part, like steel, we have to do it like every 5 years. For fiber, what is the suggested maintenance that we need to do if, let's say, we choose this material?
Actually, when I read the report from like structural antenna by Dr. Stenberg and Dr. Johnson, they don't actually focus much on maintenance because they think that the fiberglass is a maintaining material itself. But we need to consider the outside impact, the physical impact. Example, like if the people gonna crash on the tower, that we need maintenance. But if we consider it's like steel, we don't need maintenance at all. We only need to consider some other physical to impact on this one, but it's not normally we don't need to do that. That's the strength of the fiberglass.
I think, okay, part of the sustainability, we talk about sustainability just now. What I understood that material, when we consider sustainability, it should be able to undergo recycling.
Oh,
but is this fiberglass tend to be part of the recycling like steel? Once you dispose the steel structure, you can go for recycling. You can transform and you can use it again. But what about this one?
Actually, I read a report about the fiberglass, the recyclability of the fiberglass, but they said that the fiberglass is not recycled, but it can be an advantage that we can recycling in another form. Example, you cannot use the fiberglass and recycle again and make it into another fiberglass. No, if it's a fiberglass, after you recycling it, it cannot be. You already completely destroy the fiber integrity of the structure. So you can use it in another form. Example, you can use it as a table or use it grinding into a small element and fill with the cement.
So you were saying we can use this as well as in the foundation, right? As the replacement for rebar. Am I understanding correct?
Yes. We use yes.
Okay, so if we do that, by how much do we reduce the weight in steel in the foundation, and how much would we reduce cost in versus a standard foundation?
Actually, I already like in the slide, the fiberglass costs 75% weight less than steel. So we expect it to reduce at least 75% from a normal load. So, but actually in foundation, we don't, it costs a lot for fiberglass to be in foundation. So I think I don't recommend it because Just using steel using no more steel, no more rebar in foundation is enough because we don't need to consider corrosion, the oxidizing corrosion agent in the foundations.
Okay, thank you.
But in terms of the spacing, the diameter of the GFRP, is it same like the normal reinforcement? Because what I can see from the calculation is just quite similar.
Yes, it's really similar to each other, but in terms of all the property, it's quite similar. But it has one thing that over the steel is have a lot of tensile strength. So in terms of tensile strength, fiberglass took a lot of over the steel.
Any further questions from our panel judges?
No, thank you.
Okay, thank you,
Thank you.
panel judges, and thank you, Team AUPP from the American University of Phnom Penh, Cambodia.
Thank you. Good luck. Goodbye.
Yeah.
Yes, you did.
Okay. We have a slight change to the next team presenting because of technical challenges. Panel judges, the next team that will be presenting their ideas and innovation for today will be Team GFA from the University Putra Malaysia, Malaysia. So with that, we welcome Team GFA from University Putra Malaysia. The floor is yours.
Okay. Hi, Assalamualaikum, and good evening to all the judges and teammates. So today we want to present about our design of telecom tower and lamp pole. Without further delay, I will start with the telecom tower. So this is our design characteristic that we take from the technical framework report and technical framework. So this is our steel strength and concrete grades. Both of these we get from analysis on StatPro. And move on next. So this is our telecom tower idea. So first idea is self-supporting tower, which is 5 meter on top, which is vertical straight structure. This is because to reduce steel, and secondly is rough foundation to reduce differential settlement of the soil bearing. Because the soil bearing is strong, but strong enough to support the loading, but the wind speed is too high, which is, if I'm not mistaken, is 58 millimeter per second or 210 kph. So we need the rough foundation to support all the loading. So why we use the rough foundation is another one is to increase the structural stress. So next is all of this idea with I think it is save money and spaces. So the telecom tower planning is inclined structure and vertical structure combined on the top, like I said before. Secondly, use high steel strength instead of GFRP because GFRP is very stiff and not easy to bend. So we choose steel because the structure is too high. It might be failure if we use GFRP. So third planning is decrease the number of steel size and decrease the number of steel and size of the base. Next, also this is our drawing, which is all the details are in here, and this is our stakeholder that involved in the in this telecom tower. So move on to the next slide. I will pass to my teammate Fitri. Thank you.
Okay, thank you. So I will continue about the our lamp pole design. So first of all, this is our lamp pole characteristic based on the technical framework, and we decided to use the steel strength is to use 275 Newton per millimeter per second, and the concrete grade for the base is 35 Newton per millimeter per second. Next. So for our design lamp pole idea, first of all, we are going to use solar energy as a power sources, and then it will lower the power consumption, and for sure it is eco-friendly environment as they are energy efficient and low maintenance. Next. So for the lamp pole planning, first of all, we are going to using the solar panel on the top of the lamp pole as to absorb the sunlight, so that it can generate electrical energy. And then we'll be using the LED. And by using the solar power, and it only we can maintain once in a while. Next. So these are our detailed drawing of lamp pole. Next. So these are the order that will be going to involve for the lamp pole design. Next. So what is the impact to edotco and business information? So first of all, our design will be going budget, and due to the for the sustainable, it can decrease the manpower as it will less to be have to maintenance, and for sure our design is to promote a safe environment. So it will be trust with the customers, and last but not least, it will allow the company to grow. Next. So for conclusion and recommendation, why our design is sustainable? This is because for the telecom tower, it is self-supported tower as stated by my friend just now, and rough foundation, and for sure it is all safe cost and spaces. And for the lamp pole, it uses solar energy as a power sources, so it will store in the battery the electric energy, and then during night it will be switch on the light. And then for sure our design is low power consumption, and it is eco-friendly environment as they are energy efficient and low maintenance. Next. I think that's all from us. Thank you.
Thank you. May we proceed with the Q&A for the judges, if you have any Q&As for the panelists, finalists?
Yeah, I have two questions on the lamp pole. The load, what's the wind load that we can load on the tower? That's one. And two, the solar energy that you've deployed on the lamp pole, how much does it generate electricity? I just want to understand the input of that, output of that. Those are the two questions. Thank you.
So for the wind load, for the lamp pole is around 1.77 kilonewton per meter squared, which is in velocity pressure, or 50 meter per second, the wind load. So next question, I will pass to Fitri.
Hello. Sorry. For the power, we have not get the detail how much that it required for the power to consume. But as we thought that during day, the solar panel get enough time to absorb the sunlight, so that it can store in the battery. So during night, it might have enough electric energy to switch on the light.
Okay, so that power source is only for the LED to power the LED light, right?
Yes.
Okay, got it. Thank you.
Yeah, welcome.
Okay, I have the same question. I mean, not the same question. Similar to Mr. Ricky, still on the lamp pole. Yeah. Just now you did mention, yes, a lamp pole can save budget in terms of electricity and so on. But in terms of maintenance, did you calculate and then the battery that you will use? Of course, the solar will need to have a battery. So did you take into account the maintenance and the battery replacement?
From my research, the battery maintenance for the solar lamp pole is around 2 months. The company or contractor will change one battery in 2 months time. So it takes about in a while to change the battery.
Okay.
Okay, one more thing, about the solar panel. Yeah, we put the solar panel on top. Look at your design, something like a conceal on top. How about the maintenance of the solar panel? How easy can we go to reach this? Maybe, I don't know, maybe some cleaning. If let's say some part of area where you deploy this lamp pole, maybe birds like to hang around, and there will be a lot of dropping from the the bird, for example, then will reduce your efficiency of your energy absorption on your solar panel itself. Is there anything, some measures that we can do, how to tackle on this?
I will pass this question to Fitri.
I think that we might not figure out until that kind of thing. But from our research that we are going to design the lamp pole at the top of the solar panel. There will be like a cover. It's not cover. What we call it? Like
screen or something.
Yeah, something like that to protect the solar panel.
And for your battery, I believe that you need to have sort of a storage area at the bottom of the pole. That might be, you need to consider how it look like to blend in with your lamp pole. Look at the dimension, whether the battery can fit in. I think that's another thing to be considered as well.
Yes, on the top of the lamp pole, which is the oval shape, there is some space in there that we have provided to put the batteries. That section is specifically for the batteries. So from that, it can save the budget because we only can use like cable, only short cable to connect battery and to LED, and also to the solar panel.
All right. Then you need to consider again your pole size, because of the load that you put. The battery is not I can say not a light structure. It become heavier on top, and look at the design will be slender on top. So I think maybe you need to consider as well that maybe the sizing of the pole itself to accommodate the load of the battery, because you put it on top.
Yes, we have considered it in the analysis. We use steel, not GFRP. So it might the steel might help a lot when we install the battery on the top.
Okay.
Thank you.
How do you place the solar panel? Is it horizontally, or do you have any angle to place because you know that there is a certain angle that the solar panel can catch the maximum energy from the sun. How do you place the solar panel? Is it horizontally?
As the sun facing, depends lah what side ada. So some facing macam tu je.
We place the solar panel on the top of the lamp pole is horizontally on the oval shape.
Okay. Yeah, I agree with Dr. Siti. Certain angle you need to maintain, to get the maximum of the sun ray. Because at certain time of the at certain month of the the sun. I think the eclipse things. No eclipse. The sun move actually based on your. I can't remember the name. The name. Yeah.
Yeah.
Because of the angle of the sun will change periodically as per season. Yeah, that one you need to consider as well.
Okay.
Also for urban areas, you know, shading as
Yeah.
buildings are going up.
Yep.
Yeah, you have to be very, very mindful of that.
Okay.
Okay.
Okay, thank you.
Okay, thank you, panel judges, and thank you, well done to Team GFA from University Putra Malaysia. We hope that you have taken note some of the points given by our panel of judges, and with that, I think you can further improve your knowledge and, of course, your presentation for the future. Yeah, good luck, boys. Thank you.
Thank you.
Okay, thank you.
Great. Okay, so we are moving on to the next team presenting. We'll just give a few minutes for the transition. Let me just check if the teams are ready. The team is ready.
One of the students still in the meet.
Fitri still.
Leaving. You 10 seconds.
Okay, check this UDT ada tak?
Cuit ready? Cuit.
Yes, we are ready.
Ready?
Okay, so moving on, ladies and gentlemen, the next team pitching their ideas will be from team CUET Dom Ketu from the Chittagong University of Engineering and Technology, Bangladesh. The floor is yours, Asif.
Yes. Honorable judges and mentors, Assalamu alaikum. I am Asif Jawad from Chittagong University of Engineering and Technology. Presenting the site on regular telecom tower for urban and rural areas. Our team name is Chuet Dumketu, and our team members are Mohammad Nasmul Haq, Talal Mahamud, and I am Asif Jawad. Background of this study. Telecom towers are becoming increasingly important in this age of information and technology. As a result, the construction of sustainable telecom towers with modern facilities is required. So to deal with the rising modern telecommunication system, our group is attempting to provide a modern solution with an innovative telecom tower idea. Executive summary of this study. Regular telecom tower for urban and rural areas is designed by SAP 2000 version 22. Here we use steel grade S355. But we want to design this telecom tower with fiber concrete molded timber pipe. For this purpose, we collect all the materials specifications and properties. When we assign this material in SAP 2000 version 22, the software cannot design this type of material because of software limitations. So we replace this material with steel. If fiber concrete molded timber pipe is used in telecom towers, it can be a unique innovation with better feasibility and functionality. Also, it is a cost-effective and environment-friendly material. Resource optimization. Here, less steel is required. Fiber concrete molded timber pipe is cheaper than concrete and steel. Feasibility, practicality, and functionality. Design met all specifications provided in the technical framework, and it can be made locally. The local firm has the technical competency to implement such a design, and land usage is optimized. The environmental impact of fiber concrete molded timber pipe, high carbon footprint reduction, and it is camouflaged, and it has aesthetic appeal also. Here all the AutoCAD drawings, plan and elevation of the tower. All leg cross section and all horizontal and vertical bracing cross-section designed by SAP 2000 version 22. Here we also used additional features, wind turbine, is plan view and elevation here. Horizontal bracing cross-section at different elevation. Structural design, SAP 2000 version 22 model. Here the plan and 3D modeling of the tower. Total number of nodes is 69 and total number of members is 174. Plan view of foundation details and base plate with anchorage. Elevation view of foundation details and base plate with anchorage also. Anchor detailing here. Rebar mesh of foundation. Here we used concrete 4000 psi and rebar of 60 grade. Cross section of rebar mesh with anchorage. 3D render model of our tower. Some pictures of 3D modeling designed by Lumion 10. Bill of quantity. For tower, the total cost is $9,700, and for foundation, the total cost is $1,149. Recommendations is we strongly advise that conventional telecom towers be replaced with fiber concrete molded timber pipe to ensure a long-lasting, cost-effective, and environmentally friendly telecom tower. Conclusions. We are focusing on innovation, cost efficiency, feasibility, and functionality, and environmental friendliness during this edotco infrastructure design competition. In this regard, the fiber concrete molded timber pipe telecom tower will be a timely, high quality, and cost-effective construction solution. Thank you, everyone.
Thank you for your presentation, and we now open the floor for Q&A. Panel of judges.
So I understand the members would be fiber concrete molded timber pipe, right? And even the cross members.
Yes, yes.
Yes, sir.
Okay, and what is the timeline of fabricating? I just want to understand the process of fabrication and timeline versus a normal steel process. Maybe you can talk me through that, and in terms of the process, and then also the transportation, etc., versus the steel.
Sir, please again.
Okay, sorry. I would like to understand the fabrication process of this concrete molded timber solution versus, you know, the fabrication for steel. I think it's pretty obvious how that's been done. I just want to understand the process of fabrication. How do you fabricate these ones?
It can be locally fabricated.
The method, maybe you can just explain to me the method, the raw materials that they get, maybe just roughly the method of fabrication.
Firstly, in timber pipe is taken, and then it's fabricated with concrete. That's
Okay. There's no special molds that needs to be created and for this process, and then as the special wood, or you can just take any type of timber and the concrete strength. Maybe do you have some of that information?
Sir, no, sir. At that moment, we have no information about it.
Okay. Thank you.
Okay. Just now you did mention about the fiber concrete molded timber pipe that you use in your design, but can I know what is the material properties of this?
Compressive strength is 38.2 MPa. Fiber
Sorry, again?
is compressive strength of fiber concrete.
Yeah.
38.2 MPa. And fiber used as a polymer, 3%.
Okay. And then you also have wind turbine on top of your tower. So can you explain a little bit on what is the function of this? I mean, you introduced to have this wind turbine in your design?
Ma'am, please again.
Can you explain a little bit on the function of wind turbine to be included in your design, in your tower communication design? What is the function?
Yes, it is a vertical turbine where it's flowing. It's when wind come from wind side or lee side, the turbine is rotating and energy produces.
So meaning that is being used to transform the energy, yeah?
Ma'am, please again.
Okay. It's okay. I can understand that.
I have one question here. Yeah, you talk about this material, fiber, concrete, molded timber pipe. In normal application, where we can see this type of material use? Not talking about tower, in normal application, anywhere is it been used?
Sir, please again.
Okay, this fiber concrete molded timber pipe, the material that you propose for the tower. So I want to know, what is there any normal application beside tower that you can find this material used?
No, sir.
So never been used before?
Yes, sir.
Right. Very interesting, eh?
So if this material never been used before, so what made you choose to have this to be introduced in this tower design?
It is lightweight and compressive strength is very good.
Yeah, but the thing is that the challenge that we will feel, that I feel, yeah, later on, if let's say somebody want to build using this material, whether there is any, let's say, production, any factory can produce this.
Sir, yeah, it can maybe, but we think it's a lightweight materials, and it can take more compressive strength. So we think it can be innovative ideas for telecom tower.
Is there any factory having this material in Bangladesh?
No, sir.
No. Okay.
So this idea just you just the team just sat and you put these materials together as an idea.
Sir, we think there should be new factory for making this type of materials,
okay,
or molding or shuttering this type of timber pipe.
Okay. Okay, now interesting. I just want to understand how you came about this idea. Is there something that you looked at? Is there an example that you applied it, or it's just interesting that this idea, how it came together? We would just understand how this idea was formed.
Or is there any research has been done on this material?
We think the replacement of steel, then we think it can be a better solution, and it can be a economic solution and environmental friendly solution also.
Okay, continue to Dr. Siti Aminah question. Is there any research done? Is it Chuet University has done this research on this?
No, sir, in Chuet, and sir, but we wanted to research in that, in this material.
Okay, there is no research done. So totally, this is I can conclude that this is a new material that you feel can be a replacement to steel to produce tower, yeah?
Yes, sir.
Okay. Then I believe that a lot of things need to be done in terms of the property strength, the maintenance, how if let's say we build tower, what about the UV attack to the structure? Can it last? So, yeah. Okay, thank you.
Okay, thank you, panel judges. And of course, to team CUET, Lumketu from Chittagong University of Engineering and Technology, Bangladesh. We thank you for your kind presentation. And do take note some of the observation made by our panel of judges. It may help you to improve some of the points that you have presented. And of course, to strengthen the facts that you'll be pushing forward your ideas for the coming future. Thank you once again, everyone, for your kind presentation.
Thank you, sir.
Thank you, sir.
Is it okay, Is it?
Yeah, I'm good.
Okay, and our final team presenting for this grand finale, ladies and gentlemen, please welcome Team UET Lahore from the University of Engineering and Technology, Lahore, Pakistan. Yeah, okay, so they're having a transition.
Hello, everyone.
Hello, Team UET, are you ready?
Yes, we are ready.
Okay, great. So with that, the floor is yours, Team UET.
Can you please elaborate?
The floor is yours. You may proceed. You can start.
Can you please speak? We can. Can you give us the control, please?
Can we have the control? Yeah. Yes, you can. You can.
Yeah.
All right. Good luck.
So, should we start?
Yes, please. Go ahead.
Okay. Thank you. Please give us the control.
Can you kindly request for control? We will give you access. Yeah. Hold on.
Slides are not showing here.
Just give it a minute. Just give it a minute.
Okay.
Okay, can you request for control?
Still not presenting the slides.
Can you request for control? Okay, you yes. Have control of this presentation.
Yes.
Okay, good luck. The floor is yours.
Thank you. So, hello everyone. We are from UET Lahore. Our basic telecommunication tower is based on very sleek and cost-friendly structure. When we talk about the cost-friendly and sleek structure, we can go into something very lavish, or we can't talk about something very innovative. But when we look into the technologies we have in these years, we have developed these years, we can go further, and we would like to present our tower as something which may look typical, but which is not very much typical. And the innovation technology we have used is certainly going to change the current scenarios for Malaysian environment, and obviously for the further when they will be implemented in the environment. Just a second, our slides are not loading actually.
We're checking. Hold
Yes.
on.
So here is the basic definition of the telecommunication tower, which is primarily there to hold the telecommunication antennas. And when we talk about its service and information, it is very basic for the mobile service. A tower could be more than just be holding antennas, and here we are presenting our technology which we implemented into our tower in order to create some innovation. And here is the technology which we introduced into our tower. When we talk about solid state wind energy transformer, this is a very innovative and developmental phenomena in which aluminium wire are installed into the tower, and small ionic charges are passed through these wires. And when air particles travel through these wires, they carry the negative charge with them into the ground, and hence we are merely left with the positive charges, and hence the negative charges from the ground start traveling into these wires and hence create the electricity for our environment. So introducing this technology into our tower would help it make a self-sufficient tower which would be supporting itself as well as creating electricity for the environment. When we talk about typical method of producing electricity from the wind, the general method we use are windmills. Windmills are very much hazardous to the birds. When we talk about these population of the birds which are killed due to these large metal windmills, the number is very large. Also, the windmills are used at the large scale, and the small scale production is not very much possible here. So when we talk about these windmills, we are not talking about something which could be maintained easily, which could not wear or tear, or which could not produce the noise. When we talk about solid state wind energy, this comes with its own advantages. Although it is a developmental technology, still in the experimentation, but when we talk about this technology, this comes with a very low maintenance cost, very small or either no wear or tear, and also no noise pollution. So when we talk about these advantages of the solid state wind energy, these are very efficient, and also we have some recommendations for the material which would be applying on the tower. When we talk about the material, it is a titanium dioxide which would be applied to the tower, and the titanium dioxide is very much a material which would stop the air pollution. When we talk about the towers installation into the urban areas where pollution is very large, the material like these would be very efficient. Titanium dioxide convert the harmful.
Sorry, Ms. Nurul, we have to interrupt you. Judges, yes. Are you able to see the slide that is being presented? No. Sorry, Ms. Nurul, we have to take control of your presentation because I think there's a network lag. And
okay.
At which page are you at now?
We are at page number 5.
Okay, hold on. So
page number 5.
Okay, page number 5. We will move the slides on your behalf as you
Please move
yeah?
to page number 7, please.
Page number 7.
Yes.
Okay. Okay. So once you're ready to move to the next slide, just mention next. Yeah. Okay. Thank you.
Okay. Okay, thank you. So when we talk about this material, this very effectively reduces the air pollution made from the lightweight transformed plastic panels, a standardized system for interior and exterior application. So semi-customizable to the project conditions and an innovative and eco-friendly product. This product would certainly be used into the densely populated areas where air pollution is very high, and this material would, when applied to the tower will itself act as an eco-friendly entity, and it would convert the harmful air, which is nitrogen dioxide, sulfur dioxide, or any other harmful particles into neutral air particles. Next, please.
Hi guys, from now I will tell you about the structural description of this tower. The type of telecom tower that we have selected is a self-supporting greenfield tower because that fits all our recommendations. Page number 9, sir. Okay, and in order to find the critical member forces, we have done two types of analysis here: wind load analysis and seismic analysis.
Next.
Next page, please. Next page, please. Yes. For the previous page.
Very good afternoon. Very good afternoon, esteemed judges for today's competition, ladies and gentlemen. Very good afternoon, esteemed judges for today's competition, ladies and gentlemen. First and foremost, I would like to thank you for tuning in to the closing ceremony of our very good afternoon, esteemed very good afternoon, esteemed judges for today's competition.
That we have to analyze to carry out the wind load analysis. The first case is only for the self weight. The second, when the wind load acts perpendicularly to the member, and the third case is when the wind is parallel to the diagonal. Next page, please. Next page, please. Actually, the edotco technical framework does not provide us any of the constants and the recommendations for the seismic analysis. So I have taken only the general considerations for the seismic analysis, because for the steel structures the seismic analysis is not that much critical. The importance factor I have taken as 1. However, for the telecommunication towers, the UBC 97 tells us to take an importance factors of 1.25. The reason for which I have taken importance factor equal to 1 because the category given by the edotco technical form work was satisfying the importance factor equal to 1. And the soil type I have taken as SD and seismic zone as 2A and the near source factors NA and V equal to 1. And next page please. I have carried out the design based on both of these seismic analysis as well as the wind load analysis, and the most critical member force we came from the wind load analysis, and I have followed LRFD method to design the members as tension and compression members. Next page please. Next page please. Now talking about the movement releases that we have provided. These are to prohibit the transfer of movement between the members. Actually, the movement releases here act as a pin joint, so that the movement may not be transferred to the next structural member. And next page please. The bill of quantities I have also calculated for the different members we have selected here, and I have cumulated all of them to find the final cost. The total structure cost without the labor cost is actually $14,740, and that was found to be very quite economical for a telecommunication tower. Next page please.
Hence, we introduce the solid state wind energy to as our design is cost efficient, so we try to induce some renewable energy resource in our tower in order to make it self-sufficient, in order to make it environment friendly, and in order to create a self-sustainable system for our environment and for the Malaysian environment. Thank you so much. Next page please. So these are our render views of our tower, which we have taken from the point where the aluminium wires are provided to the lower left corner, and the top four panels are provided in this tower, and we could introduce this technology in any compartment of our tower based on the need of the energy in the area. Thank you so much. Can you place the animation, please?
Okay, great presentation from UET Lahore from Pakistan. So we now open the floor for question and answers from our esteemed panel judges.
Can I start first?
Yes,
Okay,
Go ahead,
thank you.
Doctor.
Okay, okay, thank you. It's interesting to see you introduce this solid state wind energy transformer in your tower design. So can you explain to me what is the height of the aluminum wires that you use in your tower, and where is the location of the aluminum wires? Yeah, because you can see because you introduce this to cater or to transform the wind into the energy. So we know that the wind come from many angles. So did you take into account at which angle or which side the aluminum wires to be the suitable place to be placed? I mean the aluminum wires, yeah. What is the
Actually,
height?
the aluminium wire is to be placed between the two consecutive faces like this. So that if the wind is flowing from this direction, so it may intercept the aluminium wires and may freely go off from the other face. And if the wind is coming from this direction, it may interface this face of the tower and may go freely from the other end. And the height of the aluminium tower, height of the aluminium wire can be changed accordingly. It can be it can be placed in all of the complete tower, two consecutive faces.
Okay, thank you.
Thank you.
How much electricity do you think this could generate? One, and is it a health and safety issue if somebody is working on the tower or climbing the tower and the tower becomes a conduit for electricity? Is there any risk for people?
Actually, this method is currently in the developmental phase. When it was experimented, small amount of energy was produced in the experimental method. This could be generated according to our need. When we are talking about this design, we could implement it our way. The amount of energy we need or the amount of energy we want to produce from this tower, it depends upon us. So this is currently a developmental and experimental phenomena which we incorporated into our tower. Also, this could be when negative charge is passed through aluminium wires, then electricity is produced. So if anybody is working on the tower, we could just stop the current passing through the wires and we could make it a safe approach for the people working there.
Excuse me, and for additional safety, there is also a thing I would also tell you that the main electricity that is passing is actually on the two extreme corners of the wire. We could also cover that with some sort of cable covering and insulating material. Thank you.
Okay, I have a question here, just echoing what Ricky has asked just now. At what wind speed we are looking at for your solid state wind energy can function? What is the speed limit we're talking about here? Sorry, not limit, the wind speed.
Wind speed.
Wind speed. Okay, the wind speed is actually between from actually minor than 150 kph, kilometers per hour. This wind speed energy method is applicable and quite efficient between 150 kPa.
So meaning I can summarize that if the area has less wind speed, like what you mentioned just now.
No. I am saying that if the speed is above 150
Understand. Understand. Okay.
It stopped working.
Okay. It stopped working. So my question
Yes.
is at what, because if I'm the tower company, I want to deploy this system, yeah, for my energy. So I want to know which area, what wind speed we are talking about that I can deploy. I don't want to invest money now to put this
Okay,
system
sir.
whereby the wind is not as good to produce energy for my tower.
The exposure category and the type of wind speed and the areas given by the edotco were quite suitable for this this solid state energy, because the wind speed in that area would not be above 150 kph. That is the maximum that we can have in those areas.
Okay, I look at your, we call it what, the titanium dioxide where you install, yeah. I look at it, you at certain height going straight to the top. So have you considered space for me to install my antenna, my radio unit, my micro dish? Because being a tower company, this space is very important for me to place all my equipment.
Actually, I said that we have placed this solid state energy on only the two consecutive phases. We can also have it on a single phase, so that we can have we can have ample space to install the flat areas and all those equipments that are necessary for our telecommunication tower.
Okay, for your information, when we install our antenna, we take the whole space, yeah. We never left behind. Depending on because depending on area, yes, on the occupancy. So normally we take all this 360 degree.